Bill blue. I don't know if this makes any difference, but I make that noise so I feel a bit about myself. Wait, is it actually doing what it's supposed to do? Does it say it's recording? Yes. Is it presenting? Yes. All right, ladies and gentlemen, under formulas, the book calls this transforming. When you get to next year, which is algebra, they will call this literal equations. Why, I don't know, or even what it means, I don't know, it doesn't matter. But what they are going to ask you to do, or what, when you get to higher levels of math, you have to be able to do is, you need to change formulas so that they do what you want them to do. For example, we've got this little formula that says distance equals rate times time. Anybody ever heard that before? Which means this: if you're in your car, David, did you drive to Indy?
Yeah.
Who drove, your mother or your father?
Father.
Is he a speedster?
Yeah.
I picture him as part of that. Let's say, what was his rate, David, would you say? Average maybe 70 miles an hour? Let's just go with that. That's his rate. He went 70 miles per hour. How many hours do you suppose, David, it took you to go to Indy? 4, 5, 4 hours? 5.
No.
Let's just go 5.
4.
Okay, let's say 4. So, at the rate of 70 miles an hour for 4 hours a time, that means young David and his family traveled 280 miles. Which, by the way, watch how labels cross off here. David said they drove at 70 miles per hour, correct? I just want to show you this. I don't care to write this down. You drove for how many hours? 5 hours, and look what happens. When I do this math, what labels cross off, and he went for 350 miles, or 280 miles. You said 4 hours, sorry. That was neither here nor there, but look at how the labels crossed off in the class. What I ask you is this, is what if David wanted to know how long it was going to take him to go to Indy? Okay, he knows the distance Indy is, he knows the rate, but how do I figure out? This is what I'm asking you in case it doesn't. I have this formula right now, but instead of me looking for the distance, I want to solve this for the time it takes me to go to Indy. I want to transform this formula so it is t equals something. Okay, what you're gonna go, well, do that one. Well, it's just like formulas. Okay, if I want to solve this equation for the letter t, what do I have to get rid of? The letter r. And this is r times t. What's the opposite of timesing? Dividing. So I can transform this formula to be solved for t if I divide by r, because that makes the r go away, and I'm left with just the t. But the other rule of equations is if I do something to one side, I have to do it to the other. So my letter r would come over here. So if I'm looking for the time something takes, it is the distance something is divided by the rate I'm going at. Does that make sense? Well, I knew my distance was 280 miles. What was my rate? 70 miles an hour, right? What would be my time? 4. That's where you go, ooh, ah.
Ooh, ah.
Or you could take this same formula. Okay, let's say I still have my distance equals rate times time, but I wanted to know what rate I was going at. How can I transform that formula to be solved for the letter r? What would I have to do, Ava Russell? By t. If I divide both sides by t, I now know that rate equals the distance I go divided by the time. Now, this is a very simple one. They will get a little more complicated. Let me show you something along the more complicated end of things. Are you ready? Say, yes, I feel as though I'm up to the challenge.
Yes, I do.
Challenge. What if I gave you this? What if I said, here is my formula. It doesn't matter what my formula is. U equals 2x plus 2. And I wanted you to solve that. By the way, you're not going to get like number answers. You're just going to get another formula that has a bunch of letters in it. If I told you I wanted you to solve that for x, in other words, I want this letter x to be by itself, and I want to know x equals what? So looking at this thing here, I need to get rid of both this plus 2 and I need to get rid of this dividing or multiplying by 2. How do I do that? Well, I always do the adding and subtracting stuff first. How do I get rid of a plus 2? One more time, Ava. Everybody, did you hear what Ava said? I subtract 2, okay? Which is good, right? Watch, here it goes. I subtract 2, it's gone, right? But I'm not done yet because if I do something to one side, I got to do it to the other. Now here's where the trouble comes in, okay? I can't do that because those are not like terms. You can't take 2 away from a u. You could take 2 away. If this said 8, you could take 2 away, but it's a u. If you can't do it, you just have to write it like this, u minus 2. That's all you can do because they're not like, you can't combine them. And now that equals 2 times x. I'm not done yet because I still have this 2 that I got to separate here. How, Grayson Tusaki? This is 2 times x. How do I get rid of a timesing 2? By 2. I divide by 2. I'm left with the x, which is what I want. What do I have to do, though? Same thing to the other side. And this is where it gets a little kind of ugly, but you just do this. U minus 2 divided by 2. U minus 2 divided by 2. You don't have to do anything more than that. I just solved that equation for the letter x, whatever that stood for. Let me give you a couple more just because. Well, let me see if they give you something hard. The one thing, man, I don't know. Do I need to go over this?
No.
Yeah, I do. Let's do one that gets a little, because we haven't seen anything like this. U equals xy over k. And I said I wanted to solve this. Actually, we'll solve this a bunch of different ways. What if I said I wanted to solve this for x? Now, where in the wide world of that sports? That sports all stuck in this whole thing over here, xy divided by k. Any thoughts? Again, thinking of opposites. Now, your thought might be this. This is x times y, so I need to divide by y. Okay, that's a good thought, except with this little k down here, that doesn't really, you can't really just take that out of that piece and do that there. Really, what you need to do is get rid of this first. How do I get rid of, let me phrase it like this. How do I get rid of a divided by k? Because what happens if I multiply this by k over 1? They cross off. But you can't just do that to one side without doing it to the other. So what do I have to do? Multiply this by k. And I end up with uk equals xy. Now, ladies and gentlemen, boys and girls, to solve for x, what has to happen here? London? To get this x by itself here, I have to. This is, let me give you, this is x times y. How do I get rid of a timesing y? I divide by y. And I divide this by y. So x equals uk divided by y. Isn't that exciting? Yes. Who said that? Congratulations. Thank you for sharing my excitement. Wait, there's got to be a harder one, don't you think? You want the hardest possible one?
This is the hardest possible.
I am going to give you one from the book. And this one I don't even expect you to understand, but I'll try. You know the Pythagorean theorem is right over there, right? It's a squared plus b squared equals c squared. Okay? If I asked you to solve that for the letter C, the first thing you would look at this, and Jake's looking at this, is I need to get the letter C by itself, right? And it is by itself, except for, this is not C equals this is C squared equals that. So here's where you have to use a little common thought process here. Remember, it's about opposites. What is the opposite of squaring something? Square root of it. Okay, which means, so this is what you have to do to it. You take the square root of this and you take the square root of that. So if I do that, C, this is C times C. Remember we just did square roots. This is the square root of C times the square root of C gives me C squared. What is C, the square root of C times the square root of C? They're identical. What happens when they're identical? You cross them off and you get just what's underneath of them. So there is my letter C. And what's on the other side? You can't really do anything with this. It is just the square root of A squared plus B squared. No, you can't do anything more with that. Now, Grace could say, does this actually work? Well, I don't know. Let's take something we know and see if it works out. Give me a Pythagorean triple that's not the easiest one. Let's say I've got this one, 5, 12, and 13, right? This is A, this is B, this is C. This is the hypotenuse of C. So here, if I put those numbers in here, if I put A and B in here, if I put this in for A and this in for B, I should get this for C, if this is actually true. What is A? So the square, watch this, square root of, what was A?
5.
So 5 squared plus, what was B?
12.
12 squared. And I take the square root of that, I should get what the letter C is. Let's try. What is 5 squared? Anybody? What's 12 squared? And that should equal C. What is 25 plus 144? 169, thank you. Is the square root of 169 going to give me 17?
Or 13.
Is it going to give me 13? I was just testing it.
Yes.
Are you sure?
I'm sure.
What's 13 times 13? 39, 13, 169. The square root of 169 is, in fact, 13. And that's what C should have equaled. Congratulations. Look, you just proved our rule. All right, enough of that. What I have for you for tomorrow, ladies and gents, is this genuine worksheet here. Believe it or not. There's 2 pages to it. We already did a couple of them. We already did a couple of them. Most of them are review of stuff that you've already done. And you have like 20 minutes to accomplish it. There are 2 pages, so it should be different. I'm going to hand out the first one and then give you the second one. I would surmise there's probably enough room on this worksheet to actually do these problems on this worksheet against my data judgment. I will always do that. There are, but I do that one at a time, because it's way too slow. More helpful. I give you the same page, I give you the same page, I give you the same page. I give you the second page.
Do you want me to get this book for
You can, I'm also planning on putting it on Google Classroom, but I would take it to you.
I need 4.